For problem 17, it reads, point A is to be graphed in a quadrant, not on an axis, very important here, of the standard x, y coordinate plane below. If the x coordinate and the y coordinate of point A are to have the same signs, then point A must be located in. What's important here is to know that the point is not on an axis, because if it was on an axis, then you couldn't say that it's in one of the quadrants. For example, if we put a point here on this x-axis, would you say that it's in quadrant 1 or in quadrant 4? It's really not in either one of those quadrants because it's on the axis itself. The same for any point that happens to be on any of the axes. And so it's important to know that this is eliminating those possibilities. So now, if they're saying that point A are that the x and y coordinates are to have the same signs, in other words, for example, 2, 3, these the x and the y value here have the same signs, in this case, positives. So where would this point be? Well, if we do a scale here of 1, 2, and then 1, 2, 3, say, 2, 3 would be here. So that's quadrant 1. But that's not the only choice. You see, a point here, for example, would have a negative x value, but a positive y value, so it wouldn't apply. But what about a point on this third quadrant? Well, in this case, it'll have a negative x value and a negative y value. For example, let's do -3, -1. Both have the same signs. And so if we look at where this would plot, would be -1, -2, -3 for x, and then -1 for y. So it's right here, quadrant 3. So quadrant 3 is also a match. Now, quadrant 4 wouldn't work out because, say, if I have a point at 3, -2, which is this point right here, well, the x value has a positive sign, the y value has a negative sign, clearly not equal signs. So it's quadrants 1 and 3, and that would be choice E. For problem 18, it reads, Reggie knows how to make 5 different entrees, 4 different side dishes, and 6 different desserts. How many distinct, complete meals, each consisting of an entree, a side dish, and a dessert, can Reggie make? So we can visualize this using trees, and you'll see what I mean in a minute. So for an entree, we have 5 choices. So let's say choice 1, choice 2, choice 3, choice 4, choice 5. Then we have 4 different side dishes. Well, if you choose, say, entree 1, you would still get to pick 1, 2, 3, 4 different side dishes. Side 1, side 2, side 3, side 4. The same thing would happen if you go with entree 2. 1, 2, 3, 4. Side 1, side 2, side 3, side 4. And on with 3, 4, and 5. And then for desserts, say you choose entree 1, side 1, then you get to pick one of 6 different desserts. So it would be 1, 2, 3, 4, 5, 6. Dessert 1, dessert 2, blah, blah, blah. What you can see is happening here is that for every entree, you get to pick 4 different side dishes. And then you get to pick a total of 6 different desserts. So if you want to know how many total paths you can take, say this is one path, this is another path, this is another path for dessert 3, etc. What you need to do is multiply 5 times 4 times 6, and that'll give you the correct answer. So 5 times 4 is, of course, 20, and 20 times 6 is 120. So you have a total of 120 choices, which is choice J. And again, this tree can help you visualize why you multiply. Because again, for every entree, you have a total of 4 different side dishes. But then the same thing for the second one, 4. The third one, another 4. Fourth one, fourth entree, another 4 side dishes. And the fifth entree, another 4 side dishes. So you have 5 times 4, a total of 20 choices here. But then you still have to consider desserts, which is a total of 6 choices. For problem 18, if Reggie knows how to make 5 different entrees times 4 different sides times 6 different desserts, this is how you find the total number of combinations, complete meals that you can have.
not combinations, total complete meals. So that would be choosing 1 out of 5 entrees, 1 out of 4 side dishes, and 1 out of 6 desserts. And so you multiply each of those numbers, and you get 120 as a total number of complete meals, which is J.
Problem 19 reads that a bottling plant, 10,000 liters of carbonated water are needed to produce 3,000 bottles of soda. How many liters of carbonated water are needed to produce 750 bottles of soda? So there's a couple of ways in which we can do this. One of the methods involves ratio, so we would say 10,000 liters of carbonated water for every 3,000 bottles of soda. And because we're assuming that the same proportions are kept, that's what the problem implies. What we need to know is how many liters of carbonated water we need for 750 bottles of soda. Notice that we have the bottles of soda in the same spot, the denominator, and we have the liters of carbonated water on the numerator. So essentially we're solving for x, and if we're solving for x, that means taking the 750 that's dividing it here and sending it multiplying to the other side. So we would end up with 750 times 10,000 divided by 3,000, and this will be equal to x. And if we enter this on the calculator, we're going to get the right response of 750 times 10,000 divided by 3,000, and x is equal to 2,500 liters of carbonated water, which is choice C. Now I mentioned that there was a couple of choices. We can also do what's called the rule of 3, which is as follows. And it's also involves ratios or proportions. We take the 10,000 liters of carbonated water, and this produces 3,000 bottles of soda. Now, if we want to know how many liters of carbonated water we need for 750, it sets this up. Now, when you have a rule of 3 like this one, where 10,000 gives you 3,000 bottles, x will give you 750 bottles, what you need to know is that you take the 750 times multiply by 10,000, and then whatever you get, you divide by the 3,000 over here, which is exactly what we did moments earlier. It's 750 times 10,000 divided by 3,000. And again, we're going to get the same 2,500 liters of carbon.
It takes 10,000 liters of carbonated water to produce 3,000 bottles of soda, and they want to know how many liters of carbonated water are needed to produce 750 bottles of soda. You can do this by using a ratio, a proportion type of a setup. So what happens is that since you only need 750 bottles of soda, you multiply 750 times the 10,000 liter number, and then once you get that number, you divide that by 3,000, and you get 2,500 liters of carbonated water, which is choice C.
Problem 20 reads, if a rectangle measures 20 meters by 48 meters, what is the length in meters of the diagonal of the rectangle? So to solve this, we draw a rectangle, and the rectangle measures 20 by 48 meters. Now we want the diagonal right here. This is the measurement we want, x. Well, since this is a rectangle, when we draw the diagonal right here, we're creating essentially a triangle that measures 20 by 48, and x would correspond to the hypotenuse. Now, we can use the Pythagorean theorem that says that the sum of the squares of the sides, in this case 20 squared plus 48 squared, is equal to the hypotenuse squared. Remember, the Pythagorean theorem typically is presented as a squared plus b squared, is equal to c squared, where a and b are the sides and c is a hypotenuse. So that's what we did over here. Now, when we do 20 squared, we got 400 plus, if we do 48 squared, we get 2,304. And this is x squared, the diagonal measurement we're after. Now when we add these two numbers, we get 2,704, and this again is equal to x squared. But we don't want the measurement of x squared. We want to know what the measurement, in other words, what x is. So what we do here is we simply take the square root of both sides. So that's the square root of 2704 is going to be equal to the square root of x squared. Now these will cancel, giving us the x value we need, and the square root of 2704 is equal to 52. So the measurement is 52 meters, which is choice.
For problem 20, we essentially have a right triangle measuring 20 by 48, and we want to find the hypotenuse, the measurement of the hypotenuse, which corresponds to the diagonal of the rectangle in that prompt. So we know that based on the Pythagorean theorem, if we square each of the sides and add those two, it should be equal to the square of the hypotenuse. So we want to know what 20 squared, which is one of the sides, plus 48 squared for the other side, what the sum is. So that sum is going to be equal to 2,704. But the Pythagorean theorem says that the sum of the squares of the sides is equal to the square of the hypotenuse. In other words, this value corresponds to the square of the hypotenuse. So we need to square root this to know what the hypotenuse actually measures. So to get the square root, remember it's the second for blue and the root symbol above the x squared key right here. So second square root. We can just do the answer, which is that key here, or we can just write 2704. So let's use the answer key, so second and then the negative sign for answer. So the square root of the answer means the square root of 2704, which is 52, and that gives us the correct answer, which is F. Or we could have just done the square root and then just key in 2704 and same answer, of course, 52.